everyone, Hamster Boy here, and today I got a box. Ooh, so excited. Feels like Christmas, which, to be fair, it's like almost December, so, close enough. Ooh, yeah, no, this is something I've seen Steave Mould do a video on a while ago. And, yeah, let's open her up. Alright, that should do it. And da 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 da. Right. Right. Get this box out of here. Hey! Okay, sorry. Apologies about the lighting. Normally I do these recordings at nighttime. I have a window right there. And so, yeah, normally I do it nighttime when it's dark, and so, yeah, you can see the reflection of the sunlight. But, yeah! I got Spintronics Act One. I should be getting Act 2 soon, hopefully, and the power pack, but, yeah! Oh, so excited! Ooh! Let's open her up. Yeah, no, okay, so, quickly to mention, like I said, I saw a YouTube channel called Steave Mould do, great channel by the way, does a lot of interesting science videos. As a side note, one of my favorite was his little rivalry between him and Electro Boom about how chain fountains work. Really cool little back and forth, love that. But anyway, yeah, he did a video about Spintronics, so as soon as I saw the video, my mind was blown, so, as you've seen, I'm a bit of an electronic nerd. I love electrical machines and electronics, and I love logic gates, I love circuits, I love computation. Absolutely my jam. But I'm also, okay, I can't really get it out for you, but it's good. I have these. I also am a big mechanical nerd. I have this set of gears as just a fiddle toy. I have this little gearbox motor from Snap Circuits. And yeah, if you've seen my other videos, I made that tumbling avalanche, which is mechanical. Pulley contraption, mechanical. I'm a big mechanical guy, and so yeah, I love mechanical technology. It's one of my favorites, and something that I really love is the intersection between mechanics and logic. Like, something that blew my mind when I first discovered it, but the idea of mechanical computation just, it's a marriage made in heaven. It is the most steampunk thing you can think of. At least I can. I love it. Like, yeah. Charles Babbage is a bit of a hero. So, and don't get me started on the brilliance that is the Curta calculator. So, alright. Let's see what we got. So yeah, long story short, he did a video on this, and it's basically a mechanical analogy of an electronic circuit, which, okay, that's pretty cool. I'll just say, I apologize for the lighting, but I love the packaging. I love the sort of steampunk inspired, like this beautiful sort of art. I'm not sorry, I'm not a font guy. I don't know my technical names, but I just love this font, like this sort of Victorian style. Like I love that you got these little highlight bands inside the font. Really beautifully laid out. This nice cream color background. The main contraption, full display, beautiful artwork. According to the website, there's also like an instruction book with some really beautiful like comic book art inside of it. Just a gorgeous packaging. Yeah, no, ooh, I'm so excited. Alright, enough gushing about the box. Let's see what's on the inside. Da 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 da. I'll set the box gently to one side. I will be using that later. Alright, Spintronics Act One. Oh, nice. Okay, it's got a... Oh, wow. Oh, that's nice. Okay, so it's metal bound. It's not a plastic binding. Nice. Plastic front and back covers, which is nice. I'm not a fan of the texture personally. I don't like rough plastic. It's a little personal pet peeve of mine, but that's more of a personal issue than a quality issue. So yeah, we got this book, which, oh, that's nice. Okay. Sorry, let me show the camera. Oh, they have exploded diagrams of the machines. Oh, that's really cool. Okay. Ooh. And then you have the spoilers at the back. Makes sense. Okay, so that's the book. I'll gently set you down there. And then the meat and potatoes of this are the components themselves. So we have these... Ooh, very shiny. Let's see. Hello! Ah, there we go. Hello! And then, hey look, it's you! Okay, okay, if I'm gonna be nitpicking, which I am, there's a bit of dirt on the metal plate right from the factory. It's nothing. I can probably just wipe that off, but like, if I'm gonna criticize anything, yeah. It's a shame that it's not a perfect mirror right from the factory. Yeah, which I'm guessing this is from the parts being handled out of the factory. Okay, so they are... Okay, so it is folded metal. So yeah, looking closely, it looks like it's a metal sheet that's been folded over, and then you have it basically pressed into this plastic. I'm not entirely sure what these are. I'm wondering if they're just weights or if they have a function inside them. Interesting that they're sort of gold colored on the bottom and they're shiny metal on the top. Very odd. I don't understand, but I'll work with it. Another plate. Bit of packaging. Alright, plastic key. Okay, from the box I thought this was going to be a cylinder. Or from like the product listing, I thought this was going to be a cylinder. Turns out it's actually hollow on the backside. I mean, I get it, yeah, it saves weight and whatnot, but I'll admit, it's a little disappointing to see it on the backside, but whatever. I will say though, I don't know if this camera will ever pick it up, but yeah, there we go. Yeah, I love the ornamentation on the handle of the key itself. That is really nice. Like, really good design all around. And so yeah, this is supposed to interact with these little elements here, which are little connectors, and from what I understand, these plates are supposed to join together. Oh, I see, they just simply sit. And then, oh, I get it. Okay, yeah. Oh, that's neat. Okay, and so yeah, these two fit together, and yeah, you don't really even need the key. Like, there's plenty of room for just fingers to get in there. Like, I think the key is just, I don't know, maybe a little bit of a gimmick, a bit of a novelty, maybe for the play of it, but yeah, there's plenty of room for fingers alone. And while I don't want to test it too much, it does seem somewhat sturdy. At least it's able to hold its shape. But I don't know, these seem a little bit small. Like, they'll be good enough to just hold it on the table, sitting flat, but I would not try to pick up a large model and move it about with these small tabs. That is something I am a little concerned about. Yeah, and yeah, you get these like long cantilevered bits of plastic. Like, admittedly, it is held in here, so you got this bit of meaty plastic here, but yeah, definitely not a toy for rough kids. I'll put it that way. It is nice, but yeah, not something to be abused. It is something that, you know, should be played with a reasonable amount of gentleness. Delicious desiccant. A bunch of chain links. Some assembly required. Oh, okay, they do come with blue links. Okay, oh, that's cool. Okay, so, yeah, no, that's something I find interesting. So, in Steave Mould's video, I saw that they had a couple of blue links going around each circuit. And I'm like, oh, that's neat. That's really cool to see the blue link move around and watch the chain, like, go around. But in all of the advertising, like, on the official website, in all of the little, like, promotional videos and whatnot, it was all black chain. No blue link whatsoever. And I'm like, so is that something Steave did himself? Is that a custom piece? I think he has a 3D printer. Maybe he 3D printed it just to show the audience. Maybe he painted it. I don't know. So I was very concerned. Like, do I have to make a custom blue piece? I want something. I like that. I like having a piece that's obvious to move around. But turns out, no. It actually comes with a few of these blue links. Very nice. One other thing I'm very curious about is, at least design-wise, these links look very much like Lego chain. I'm curious if they use the same module. I need to double check, but if this will work for Lego, hey, there's an idea. So that's chain, more connectors, and then we got the main components. Some foam, good packaging. Actually, speaking of the packaging, again, I'm not sure if you'll see, but I like that. Okay, so it is just like a vacuum formed piece of plastic to hold everything in. Fair enough. But I appreciate that they put little rivet details on and little bit of like paneling details as well to make it look like it's a bunch of riveted panels that was assembled together. I appreciate that. Nice. Going with the steampunk aesthetic, and just even in the packaging, they're sort of running with that idea. Really nice, really nice. Okay, so many parts. What should I look at first? You know what, let's look at the big one. The motor. The battery. Oh, wow. This, admittedly, it's a lot thicker than I imagined it to be. Yeah. Alright, so if I pull it back, I'm probably gonna put like a little mark on one of these. Oh, that's nice. That's nice that it has an overrun clutch. Oh, wow. Okay, I'm not sure if you'll be able to see. You can see there, they have ball bearings. They use actual ball bearings in this. Oh, that is quality. That is quality right there. Oh, that is wicked. Shoot. What type of screws did I use? Or is it screwed? Or is it riveted? Oh, it's screwed from the top. I'm a dummy. I'm looking at the bottom, like, so you have these, like, what looks like screw holes, and normally toys are screwed in from the bottom, where the screws are less visible. No, they intentionally put the screws in the top. I'm willing to bet that all of these exposed screws actually are mechanically used to hold the thing together. They're not just aesthetic. I'm willing to bet that, which... something's loose. I'm guessing that's intentional. Oh, it's probably the overrun. Right, so a feature which I'm told there is if you pull it back and then let it go really fast, it should have an automatic brake to stop it from destroying itself. And I'm very curious how that mechanism works. Also, I'm told that this is supposed to have a very sort of constant tension throughout the entire travel of its motion, which, for science, is smart. You want to represent a battery by something that provides constant voltage, or in this case, constant torque. But I'm curious, like, what technology they're using to achieve this constant torque. Is it a spiraled S-spring that goes around 2 pulleys? Is it a single spiral spring that is just pre-tensioned? Or is there something else? I know in like Victorian watches, like really high-end watches, one way of doing that is having a spiral drum. So you have a pair of drums with a chain around them. One drum is cylindrical, the other one is this sort of spiral shape. Sort of a spiral mountain, and the idea was that because it's a spiral, the ratio between the two drums changes as it moves, and as a result, the torque output changes, and if designed right, the two should cancel each other out, like the torque and the spring's torque should cancel it out, and so you have a constant torque system. Very clever, very high-end watches, but those are really teeny tiny chains, and if they break, that chain whips around inside your delicate watch and just shatters everything. So, yeah, not the best, but really cool technology. But so yeah, this is the battery. And can I just say, I love that they have the exposed gears, or like visible gears, like the clear plastic plate on top. That is so wonderful. Oh, and another detail, again, on all the components, they have the electrical diagram symbol somewhere on it. And so the battery has this positive negative battery symbol on it, which is, yeah, a really nice, like, yeah, this is a 2-cell battery, but whatever. I mean, considering it is 6 spin volts, which, actually, that's what, like, about 5 AA's, give or take. Depends on the battery chemistry, of course. The batteries I'm using have about 1.5 volts fully charged. Somewhere between 1.5 and 1.2. Oh, no, sorry, not 1.5. 1.25, I mean. Correction. Fully charged, so... yeah, 4 of them together gives me 5 volts. Give or take. And so, yeah, Moving on, the next component, which I think is just an ingenious marvel of engineering, the junction. Oh, that is nice. That is smooth. Oh, oh, that is brilliant. Oh, I love that. I love that a lot. Yeah, that is so wicked. Okay, so yeah, something that Steave Mould very blatantly points out, and I think is a very interesting observation. With electrical wires, just simply having two wires joined together is a junction. Like, there's a reason why people describe electricity like water flowing through a pipe. If you have two pipes joined together like this, assuming you have water coming in one way and then two exits going out the other way, like, the water molecules will just naturally diverge. Whichever pipe has the least resistance, the water will just simply follow that. If they're about equal resistance, yeah, it'll just split. And water can dynamically choose which way it wants to go based on the loading of the system. If, let's say, you have two valves here and water goes through both of them equally, then you shut one valve, water will dynamically just go the other way because it cannot go this way because the valve's closed. And so this idea of, and then if you close or open this valve and close this one, water will then go the other way and be diverted. And this idea of having, in this case, water, but in electricity, having electricity be able to dynamically choose a direction and also go both ways if they're of equal value is, yeah, it's something that's so simple and yet also kind of fundamental to the way electronics work. Whereas in mechanical systems, it's surprisingly hard to have mechanical energy be able to choose a direction based on which way has less resistance. So there are, from my knowledge, two main technologies that are technically just like siblings of each other, and that is this was one of the technologies, a planetary gear. If I get real close, you get this beautiful little planetary gear set in here. And yeah, sorry, I might need to invest in a better macro lens. This one doesn't really do close-ups very well. But yeah, that, and that is so smooth as well. That is slick. Like, yeah. Oh my goodness. But yeah, so, yeah, like I was saying, so one of the technologies is planetary gears, where having a planetary gear, so this drives the sun, this middle one drives a ring gear, and then the bottom one is connected to the planet carrier, and then the planets, of course, are just sort of floating inside, attached to its carrier. And something you may question, well, why are they different sizes? Does one have more torque than the other? The answer is no, surprisingly enough. The mathematics works out, and I've tested this, but yeah, like, the mathematics works out such that if you hold any one of these still, and then you rotate the other one, so for example, if I hold the middle one still and rotate the bottom, the top one spins at the same, I'm gonna say rate. When I say rate, I mean, like, the number of teeth that go by is the same as the bottom one. So the bottom one turns at 1/3 the top one's speed, but it's also 3 times bigger. And so the rate of chain that goes around it is equivalent. Same thing if I hold the top one and spin the bottom one. The middle one spins at 2, what is it, like 3/3 and then 2/3, and so yeah, they are equivalent. And likewise, if I hold the bottom one and spin the middle one, again, same thing, where it's like 1/3, 2/3. And so, yeah, it all works out. So if you hold one still, that's essentially the equivalent of having that T-pipe again and closing one valve and having all the water flow out one side. Simple math, you know, if you have a pipe and one side is closed, the water goes in has to equal the water that comes out. You know, if it did not equal, then water would be building up in the pipe, and if it was less than that, there'd be a vacuum generated in the pipe. So yeah, water goes in equals water coming out. Now if both pipes are open, water coming in splits in half, and you have half water here, half water there, but the two combined is still 1 unit of water. And so that's essentially what we got here, where if all are able to spin freely, you spin the bottom one, and for every 2 lengths of chain you turn the bottom one, you get 1 length of chain on each of these, totaling 2 as a result. Now, and so yeah, this is really well done. I love how smooth this is. This is brilliant. Like, so nice. Like, you can even see the bearing. It's really, mwah, chef kiss. Mwah. My only minor nitpick, and not really a nitpick, more of question, maybe concern, maybe suggestion. I mean, it's too late now, but why planetary gear? I mean, yeah, planetary gear does the job, but why not bevel gear? Okay, maybe they're a little harder to mold, but they're not impossible. It's still fairly easy to mold. And so one way of doing it is using a differential, similar like you find on a car, where because this is a planetary gear, all 3 gears need to be of different sizes, with this one being of a dramatically large size. Whereas if you did something with a regular differential, you could house the entire thing inside this space, and then the top and bottom would be of equal size, and then the middle one would be driving the spider gears, and that would be of twice the diameter. And so, as a result, you could have small, medium, and then small again, instead of this really big, large one. And considering how common these parts are in terms of building out a circuit, yeah, you would think that having them as small and compact as possible would be an objective, but, oh well, just ideas, my personal thoughts, but I'm judging how well these are built, I have to imagine they at least put it on the table. Surely it was at least on the cards during the design phase at some point. They had to. They had to have realized that that was another possible solution, and maybe they thought it through and thought, for one reason or another, that having planetary gears was better than differentials. I don't know. I guess. Like, the two are mechanically, like, equivalent to each other in terms of their functionality. Essentially, a planetary gear is just a flat differential. Like, morphology-wise, they are equivalent. You can smoothly bend one into the other, which is really cool. What I have not seen yet, which I probably could build, is a halfway in between step where you have... It's sort of a 50-50 between a planetary and a differential. Note to self, design that in future. That would be a cool project. Moving along, we got another one of these junctions. Cool. I guess the next one I'll look at is the switch. Okay, so from factory it's locked. Very important information to know. And then I click it, And hey, it spins freely. And then I click it again, and once again it's locked. Oh, okay, cool. You can sort of see the mechanism on the inside. Okay, yeah. Yeah, you can see through this little window here. It's essentially a pen clicker, which, yeah, that makes a lot of sense. And then I'm guessing there's a sort of a clutch dog on the bottom side somewhere. Also, something I did not realize, I mean, I did realize when I picked them up, but I didn't realize until now, is that they have rubber feet on the bottom. Like, I know they have magnets, but I didn't realize that they also are rubbery on the bottom, which hopefully will give them a bit more grip. And yeah, they can spin freely. Okay, one thing which I find interesting is, so on their website they have a Spintronics simulator, which, okay, that's cool. That's cool that they actually have a simulator that you can try the thing out for free just in your browser. That is sweet. But one component they have on the simulator that they don't have in real life, at least I never saw on the page, is a level changer. They don't have any freewheeling component that just simply is cogwheels that can let you change what layer your device is on. And so, yeah, with that said, on the website, they say that using a switch, you can do the same functionality, which, yeah, okay, if the switch is just left on the on state, yeah, it basically is a freewheel. Sure, that works. That's cool. And actually, just in terms of like feel, like it's got a nice click. That is nice. That is satisfying. Click clunk. Click clunk. Now, part of me has to wonder how strong these parts are. Like, I know Steve did a test where he had an inductor going through one of these. He turned it off, and this thing just basically went flying, which hilarious. Although I'm like, eee, no, don't hurt the very expensive toy. So yeah, we'll have to see, but oh, okay. Or is it? I'm curious. Maybe the book will show. Also, I just realized these complicated gear shapes are actually 3 separate parts. You got the bottom, middle, and top, and they're just snapped together. And in fact, I think they're actually 4 parts. The 3 gear wheels on the outside, and then a hub that they all fit onto, which I guess that makes plastic injection so much easier because, yeah, doing each of these gears is like an undercut, which, as a mold designer, I know is hard. So, and not to mention the teeth need to be of high quality shape, so you can't simply split apart left and right. That won't work. So, yeah, making them as 3 individual gears and then assembling them, that's a clever solution. I like that. That is nice. So that's the switch. Right. Let's look at the resistors. So we got 3 of them. They're in little plastic. We got 200 ohm, 500 ohm, and 1000 ohm. Let's look at the small one. One other detail I like. I'll take them out of the bag. Oh, that's nice. Oh, oh, that. Just the feel of it is like, it's like butter, and I mean that in the best way possible. Like, yeah. Oh, that is smooth. That is real nice. So interesting. Okay, so they do have a sticker on the top, although it is a sticker, so I question its strength or its longevity. Like, I can see that wearing out over time. I mean, okay, hopefully nothing like disturbs it, but still, stickers are not known to last decades. But I mean, sometimes they do, but one detail I appreciate, and I don't, yeah, I don't know if you'll be able to actually make it out, but around the perimeter, you have these color bands, and the color bands are actually the correct resistor color code. So a 200 ohm is red for 2, black for 0, and then brown for multiplied by 10. So that would be 20 times 10 is 200. And so, yeah, really nice. Really cool that they include that. And the other nice thing, just from a readability, is that it's, instead of having it like a regular resistor where the bands... Alright. You know what? I can zoom in. There we go. Unlike with a regular resistor, where the bands go horizontally, the nice thing about this one is, because the bands are a ring, it means that even when in motion, when it's spinning, you can still read it. Because you can't read the numbers as they're spinning, but the bands are, in theory, still readable. Albeit they're really tiny, so... And brown and red are also very similar, so... It's a nice gesture. I don't know how practical it is. Whoops. It's a nice gesture. I don't know how practical it is, but... Yeah. A similar thing I noticed that, again, they're doing this sort of stacked thing where individual gear pieces are assembled together, which, again, it's a clever solution to a very tricky manufacturing problem. So that's a 200 ohm. As far as how they work on the inside, what I figure and what they say is, oh yeah, that's definitely a lot harder. It should be about double, slightly more than double. But yeah, essentially it is, as this old Tony calls them, well, as he did a video on it, they are rotary dampers. And I don't know if they are factory made or if they are custom built by Spintronics, but yeah, essentially what they are is there's a small chamber full of sort of like thick grease-like material. I think the website said it was silicone oil. And yeah, and basically it's a very viscous liquid that inside a small enclosed chamber, which has parts moving inside of it. And so, yeah, the oil, its viscosity naturally creates a dampening effect. And the nice thing about using a viscous fluid as opposed to doing a friction-based system, is that friction-based systems have static friction where it's you two pieces and then you apply a force and they don't want to give initially, and then as soon as they start to give, they can slide really easily, relatively speaking. And so most objects with friction, you have static friction and you have dynamic friction, which are two different values. But electronic resistors only have the dynamic resistance. They don't have static friction. So viscous fluids also have this characteristic where they have very, very low, basically non-existent static friction. And so if I apply even the smallest amount of force, it will start to rotate, albeit very slowly. Oh, that's so nice. And then we got the last one, which is the heaviest of them all, 1000, which I believe is also the highest value that Spintronics makes. Okay, yeah, that's a decent amount of resistance. Yeah. Okay, so the sun is starting to set and the environment's starting to become a bit more orange. I apologize. I'm gonna see if... Can I color balance mid-video? No. No, I cannot. Give me 1 second. Let me see if I can fix the color balance. Alright, and we are back. Yeah, I noticed it was starting to get a bit orange, so... Like, my incandescent light is very orange. It's, relatively speaking, it's very warm color compared to natural sunlight, which is comparatively very cold. But yeah, so... Very smooth, and then rather stiff. Okay, that's really cool. That is nifty. I like that. I like that a lot. Well, actually, one other suggestion they could have done is instead of varying the resistance, vary the diameter of this. Like, the larger the diameter, the more torque you can have on the same resistance. That's another way they could have done this, but I like that solution. Oh, ye happy days. Alright, and let's save... Okay, let's do this one next. This is the amp meter, which... This is a component I'm dreading. I'll admit, I'm maybe not the biggest fan of. Remember how I mentioned earlier I did not like the texture of the plastic book? I don't like this cover. Yeah, here they have a device which is just covered in this rough plastic. Ooh. Yep, just as I feared. Nope. Nope, 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 nope. Nope. It might just be me, but that is nails on a chalkboard. Nope. Moving on. Lastly, we have this, which is a Spintronics capacitor, which is a bloody clever little gadget. Yeah, it's got a little, I can zoom in. Yeah, it's got a little hairspring on the top there, and as I twist it, the spring becomes more tense. Sorry about the reflections. Yeah, it becomes more tense and... Okay, it does feel like there's a hard stop. Okay, yeah, that's nice that there's a hard stop. That it prevents overcharging. Okay, yeah, that's cool. And again, same construction of each gear being a different layer. Something else which I appreciate is... the fact that each component is visually distinct from each other. Like, you have the capacitor, which is a teal color, and it has this bright gauge on the top, or this big gauge. Does it? Does it feature the capacitance symbol anywhere? I don't know. Oh. This glass, or this plastic housing, is stationary. it's independent of the meter underneath it. Oh, that is interesting. I would have expected the whole thing to rotate, but no. Oh, that's interesting. Okay. I mean, that's cool. Right. Neat that they have 2 pointers to indicate the 2 different... Yeah, fun enough, you actually read off the pointer that's stationary. The one that moves is always at 0. But yeah, that's kind of neat. That's cool. And yeah, unfortunately, that's all the components, at least of Act 1. Okay, I guess I should take a look at this. So yeah, basically you have a piece of plastic with ridges on the top of it, and you have a little stylus needle that... There we go. Yeah, you have a little stylus needle that rides below. There we go. And then supposedly there's like a diaphragm hiding inside there, which then leads up into this, which is basically just a loudspeaker cone. Again, I love the sort of vintage steampunk theme of using this sort of old gramophone style horn, which I think actually probably functions like a horn, maybe. And yeah. Weirdly enough, I don't mind it going at slow speeds. Like that little popping sound, that little crackle. Not too bad. Yeah, still not a fan of it going at higher speeds, but whatever. Actually, you know what? Screw it. Before we move on, I have to know about the chain. I have to know, how does the chain work. I'm going to move the box to one side. Okay, so alright, so yeah, very quickly just looking at them, they do resemble that of a standard Lego chain. The molding looks a little different, but I wonder. Okay, so I know my geared fidget toy has the same module as Lego gears. And would you know, they mesh. Shoot, do I have any Lego gears around? I know I have plenty, but where? Give me a moment, let me find some Lego gears. Questions must be answered. Alright, I have returned. I got a selection of different gears. I have a teeny tiny 8-tooth. I have a medium 16-tooth. I have another medium 24-tooth. And then I have a very large, I don't know how many teeth, but this is part of a turntable. I'm not even sure if this would work with standard Lego chain, considering its weird shape. I think it'll work with standard chain, but I don't know. Fun fact, turns out the direction the chain links are facing actually does make a difference. Yeah, so you see how each link has this hook shape? Turns out, for maximum strength, you actually want the hooks facing out. So the gear rides like this, where the hooks face away from the cog. Whereas if you flip it around and have the hooks facing inwards, the chain's more likely to disassemble. Which, yeah, neat little trivia fact. And yes, you do want all the links going the same way. As they say, chain's only as strong as its weakest link. This will be fun. Alright, I think that should be good enough. Alright, so let's test. And... Aww. That's... I mean, it's close. It's really close. It almost wants to go, but it's a little bit snug around this. So, very, very, very similar, but not quite the same. But, yeah, no, that... I would not be surprised if, like, the Spintronics group use Lego gears and actual Lego chain in prototyping their product line, and I also would not be surprised if someone reverse engineered actual Lego chain to like 3D model and use for their own chain. So, alright, so I think that's enough chain. Alright, so let's bring it over. Oh yeah, that's plenty of chain. Let's... Actually, right, I'm not following my own advice. I need to clip it around this way. Alright, and so that's my length of chain. I'm gonna put it on the bottommost section. Alright, and so now I got my chain set up. Let's let her rip. Hey! Ah, that is wicked cool. And that little clickety clackety clunk as it's moving about, it's so weirdly satisfying. I love it. Ta-da! Oh, you can't see it right now, but I got the biggest grin on my face. Oh, actually, maybe you can. Yeah. Hello. Yeah, I got the biggest grin on my face right now. And so, yeah. And I love just how slowly it turns as well. It's like, I mean, yeah, it is one of the slowest or highest value resistors, but there's just something oddly satisfying about it just moving slowly and just gently. Yeah, Tony was right. Rotary dampers are cool. Alright, just for giggles, let's try a different resistor. Let's try the 200. Nice thing about being a magnetic base, it's easy to tension the chain, just simply slide them away from each other. Oh yeah, that was way faster. And yeah, if you're wondering, no, I'm not pulling the string out all the way. Dang, this is a long string. Okay. that's cool. Alright, that's cool. One minor nitpick, although I also find it kind of charming at the same time too, is I notice as this is going around, the gears are not perfectly concentric with the axle. They have a bit of a wobble to it. Slight downside in terms of quality, but like I said, it's also kind of charming. It's kind of cute how it gives it this sort of rough and tumble sort of mechanical feel to it that it has this sort of clunky feel, which I kind of like. I kind of like how it's like, you can see the parts moving about. So far, so good. My impressions are very solid. Like, nice quality parts. Very satisfying. I love the Switch. I don't know why. I think the Switch is my new favorite. The Switch. The motor's also really cool. The resistors have this nice, very satisfying, like, buttery smooth feel to them. That is so nice. Oh, and let's not forget the fun of the junctions. That is so cool that, it's like, oh, yeah. Planetary gears are pretty damn cool. And then, of course, the amp meter. We don't talk about the amp meter. Alright, so yeah, but I think I'll wrap things up here, but yeah, you folks have a great one. Very solid first impressions. I'll probably do something else with this in the future, so we'll see, but for right now, yeah, you guys take care, have a good one, and I'll catch you later. Bye.